Hi, welcome to my video on more tan graphs. I'm going to do tan graphs by the, I should say the mapping notation. And if you look at my previous unit on Trig 1, sinusoidal functions, there's videos there on using the mapping rule to graph. And I'm going to graph tan the same way. Graphing y equals a tan b theta minus h plus k using the mapping rule, where a is the vertical stretch. If a is greater than 0, tan is up. If a is less than 0, the tan is down. If b is the horizontal stretch, and the period is 180, which is the period of tan, divided by b. And h is the horizontal translation, and k is the vertical translation. Okay, let's and when we do the mapping rule, this is the basic equation for tan, and this is the in when you have a, b, h, and k added to the equation. So you have your horizontal stretch, your vertical stretch, your horizontal translation, vertical translation. So the mapping rule is theta comma y. And when we look at the x coordinate or theta, we do reciprocal of b, which is 1 over b times theta, plus the h, the opposite of the whatever is here. So if that's a negative 30 degrees, then that's a plus 30. That's a plus 30, then that's a minus 30. And the y value is a times y plus k. And this is the basic equation for the y equals tan theta. And we have 0 and tan theta. So I have a unit circle here whose radius is 1. So x is 1, y is 0, x is 0, y is 1, x is negative 1, y is 0, and here x is 0, y is negative 1. So when we do the tan, and tan is defined as the sine of theta over the cos of theta. So at negative 90, which is right here, tan is the sine, which is the y over the x, sine over cos is the y over x. We get a negative 1 over 0, which means it's undefined. And when we have a 90, which is up here, I'm just going to the undefined, 90 is sine over cos, which is 1 over 0, and again is undefined. Is undefined at negative 90 and 90. And in between that, let's just draw this diagram here, and we have a 45-degree rotation. So this is 45 degrees right here. This is a negative 45 rotating down here. The x-coordinate, because it's a 45, because this is a right angle here and here, this is a right triangle. These angles are 45 and 45. This is an isosceles triangle where the two sides are equal. So x is positive, y is positive. So the sine of the 45 is, the tan of the 45 is sine over the cos, they're equal, so we get a 1. The tan of the negative 45, this is positive, and this is negative, they're equal to each other, so we get negative 1. And the tan of 0, the sine of 0 is 0, and the cos of 0 is 1, so 0 over 1 is 0. So this is the basic table of values that I'll use for tan when I go to graph. And also, the period is the period of tan. I'm thinking about the period of tan. I'm thinking about, I wrote down period, I'm thinking about the increment. The increments is the period divided by 4. So the period of tan is 180 divided by 4. So the increment changes here are 45, so going up by 45. So if you add 45 on, you'll get, see, going up by 45. That's the increment changes. So you take the period of the function that you're dealing with and divide by 4, you get your increment changes between your values of theta here. So this is the table of value I'm going to use. So let's deal with the mapping rule. So it's theta and y. And so right here we got 2 theta, so that's a half theta, and it's 3 times y. Notice there's no degrees for theta, and there's no value for y being added or subtracted here. So that's the mapping rule. Now, if we have the mapping rule, so this is theta and y. So this is what you have to memorize. So we start at negative 90, negative 45, 0, 45, and 90. These are degrees. And so it's undefined at negative 90, undefined at 90, and at a negative 45 is negative 1. At 0, you get 0. At 45, you get a 1. So these are the values. So this half theta goes here, and this 3 theta goes here. So you take the values of theta and plug in. So I'm going to do all the values of theta first. Negative 90 half is negative 45. Negative 45 a half is negative 22 and a half. 0, take a half of it is 0. Half of 45 is 22 and a half. And a half of 90 is 45. So if it's undefined at negative 90, it's undefined at negative 45. And it's undefined here. So just write that out. And we got a 3y, so negative 1 times 3 is negative 3. 0, 3 times 0 is 0. And 3 times 1 is 3. And we want to graph this. So we're dealing with a 45, negative. So let's do negative 45 here. Negative 22 and a half, 0, 22 and a half, and 45. So I always like to put where it's undefined at first. So that's a vertical asymptote at negative 45, a vertical asymptote at positive 45, and at negative 22 and a half, you get a negative 3. So there it is there. At 0, you get a 0, which is right there. And at 22 and a half, you get a 3. There it is there. And because of vertical asymptotes, it goes like this, coming down, loops in. So there's something. Again, it's just an approximation of, and again, this is the 45, negative 45, where is undefined. Now the period is the period of tan divided by b. So the period of tan is 180 and b is 2. So the period of this function is 90. So if we go from negative 45 to 45, you get a 90. So that means there's, if you think of it, there's 2 of these between negative 90 and a 90. There's 2 of these in there. So now we say, so it's half, so instead of 90, negative 90 to 90, we have negative 45 to 45. And increment changes. The increment changes is the period of the function. I'm going to write f for function divided by 4. So the period of the function is 90 degrees right here divided by 4. So that means your increment changes in this graph should be 22 and a half. So notice 22 and a half, add on 22 and a half, add on 20, 22 and a half is between each one of these. So that's a check to see that you're doing it right. Okay, that's one of them. And again, as always, good to practice. So what is the tan? So let's look at, here's the equation, tan of a half of theta minus 90. So the mapping rule is theta and y, and the x is reciprocal of a half is 2 theta, and the opposite of negative 90 is a positive 90. And the y value, that's a 1, and that's a 0, so it's no change, it's just a y. So we have theta and y, and we have 2 theta plus 90 degrees and a y. So do you have the basic table memorized? Well, I go negative 90, negative 45, 0, 45, 90. Remember the period of tan. It starts at negative 90 and it's 180 divided by 4, so you get 45 intervals. And it's at negative 90, it's undefined. I'm just going to write UND, undefined, UND. At a negative 45, we get negative 1, 0, 1. And so take the negative 90, plug in here, we get a negative 180 plus 90 is a negative 90. Plug a 45 in, you get negative 90 plus 90 is 0. Plug in 0, 2 times 0 is 0, you get a 90. Plug in 45, 2 times 45 is 90 plus 90 is 180. And plug in 90, you get 2 times 90, 180, plus 90 is 270. And the y values, again, it's undefined right here, and undefined right here. Plug a 0 in, and you get a 0. Plug a 0 in, you plug 0 in for theta, okay? Let's plug negative 1 in for y, we get a negative 1. Plug 0 in for y, you get a 0. Plug 1 in for y, you get a 1. So, again, it's undefined at negative 90, and their intervals is 90, so we can go negative 90, that's negative 45, 0, and this is 45, make that a 90, that's 135, this is 180, and that's 225, and that's 270. So it's undefined at a negative 90. It's undefined at 270. So that's your vertical asymptotes. And at 0 degrees, you got a negative 1. 0 degrees, you have a negative 1. At 90 degrees, you have a 0. 90 degrees, you have a 0. 180 degrees, you have a 1. So the tan goes, as it goes closer and closer to 270, it goes higher and higher to infinity. It comes down and hits, and it goes down here. So there's the tan graph. And it's intersecting the x-axis at 90. And the period, so the period is the period of tan divided by b. The period of tan is 180 and b is a half. So that means you got 180 times 2 over 1. So the period is 360. So if we check it, from negative 90 to 270 is 360. And the increment changes. The increment changes is the period of f, is the period of the function divided by 4. The period of the function is 360 divided by 4. So we have a 90. So everything checks. Again, I keep repeating, going through. Pause your video if you wish and work these out before I do. So the mapping rule is theta and y, and we have 1 here, so it's just reciprocal of 1 is 1, and that's a minus 45. And the y is negative y plus 3. So it's the reciprocal of this b here, which is 1, and opposite. But here is just the negative 1 times y plus 3. And the table of values for the basic, theta and y, again, negative 90, negative 45, 0, 45, 90. You have to memorize it. Undefined, undefined, negative 45 tan is negative 1, 0, 1. And this is theta minus 45, and this is negative y plus 3. So let's plug a negative 90 into here, and we get a negative 135. Plug 45 into here, we get a negative 90. Plug a 0 into here, we get a negative 45. Plug 45 into here, and you get a 0. Notice it's going up by 45. So this is a 45. Take 90, sub it in here, you get 90 minus 45. Perfect. Now, it's undefined at negative 90, so it's undefined at a negative 135. Undefined. And negative 1. The negative of a negative 1 is 1. 1 plus 3 is 4. 0 plus 3 is 3. And the negative, take a 1. The negative of 1 is negative 1 plus 3 is 2. So we have a negative 135. And we have a negative 90. So I'll go negative 135, negative 90, negative 45, and that's 0, and this is 45. So the undefined at negative 135, there's the vertical asymptote, and the vertical asymptote at 45. And at a negative 90, right here, we have a 4. So there's the 4 there. And at negative 45, which is here, we got a 3. So there's the 3. And at 0, which is right here, we got a 2. So there's the 2. And we know, now notice this is reflected because it's negative. So instead of going this way, it's reflected down. So imagine you turn this over. So instead of going this way, it's looping down here and going like this because it's reflected. Because this is negative, it's reflected in the y is negative, it's reflected in the x-axis. So it goes like this. And you can see that it's reflected. It's reflected in the x-axis, just flipped over this way. And the period is the period of tan theta divided by b, and the period of tan theta is 100, and b is 1. So the period is 180. So just check. From negative 135 up to 45 is 180 degrees. And the increment changes, if I can spell it right, the increment changes is the period of the function divided by 4. So the period of the function is 180 divided by 4, so we have a 45. So that means these are going up by 45, which makes sense. Okay, one more to do. We got one more page here, and a final one. Again, we got a tan graph, the tan of 3 theta minus 2. Notice this is not, notice I'm repeating, this is not tan, it's the 2 is in terms of the y. So if this was, say, 30 degrees, then you would have to have it in relation to theta. But this is not a degree. This is a value of y. So just be careful. If that was 30, then you would have to be careful. Okay, the mapping rule is theta and y. And so theta is 3 times theta, so that's 1/3 of theta. And the y, that's a 1, so it's a 1 times y minus 2. And so we got theta and y. So this one is negative 90, and you got a negative 45, 0, 45, 90. The period is 180. Increments of period is 180, and 180 divided by 4, there's 45-degree increments here. And so we get undefined, negative 1, 0, 1. And we get a half theta, and we get a y minus 2. Negative 90 subbed in, we get a negative 30. Negative 45 subbed in, 1/3 is negative 15. 1/3 of 0 is 0. 45 subbed in, you get 15. 90 subbed in, you get a 30. And again, these are all degrees. I sometimes omit them, but the degrees. Now, undefined, still undefined, and negative 1 in here, negative 1, negative 2 is negative 3. Put a 0 in here, we get negative 2. Put a 1 in here, we get negative 1. And so I always, this is, okay, let's go negative 30, negative 15, 0, 15, and 30. So we have asymptotes at negative 30, asymptotes at 30, vertical asymptotes. Remember, can't cut through those asymptotes. At negative 15, you got a negative 3. Negative 15, you got a negative 3. And at 0, you got a negative 2. X is, theta is 0, you got negative 2, which is here. And at 15, which is here, you have a 1. So, tan graph goes, again, just, there it is. Again, it's approximation. Okay. Goes along by the versatile. So the closer you get to 30, the higher up it goes. The closer you get to negative 30. So this is going to infinity. This is going to negative infinity. And the period is the period of tan theta divided by b. So the period of tan is always 180, and b is 3. So 180 divided by b is 180 divided by 3 is 60. So let's check to see. From negative 30 to 30 is 60 degrees. And the increments is the period of f, period of the function, divided by 4. So the period of the function is 60 divided by 4. So the increment between these values in your table is 15. So you can see 15 is the difference each time. So that's how I graph using the mapping rule. And again, review the unit in trigonometry 1, which has sinusoidal functions, on graphing cos and sine using the mapping rule. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.